We're graphing rational functions. There are basically 7 steps that give us ideas about how to sketch a rational function. And we're going to do these without a calculator. So first, we're going to factor the top and the bottom. So when I factor the top, I get h of x is equal to x minus 3 times x plus 3 all over x minus 3 times x plus 1. We're going to look for our canceled factors first. So I see that these cancel, giving me a whole at 3 comma something. How do we find that other part? Well, remember we plug it into our simplified function. So I'm going to do 3 plus 3 over 3 plus 1. So plugging it again into my simplified function, giving us 6 over 4 or 3 over 2. So 1.5. Okay, 3 over 2. Next, I can see I have a vertical asymptote at when my denominator is equal to 0. So that would be at x is equal to -1. Next, we can look at our end behaviors or our horizontal or slant asymptotes. Remember, this is the degrees of the numerator and the denominator. So I see that h of x has leading terms of x squared over x squared plus dot dot dot. This is the degrees are equal, so we have an eats DC situation. So remember, we divide the coefficients. So our horizontal asymptote, I'm going to circle that. We're going to have a horizontal asymptote at y is equal to, my leading term is 1 over 1, so 1. Okay. Next, to find the y-intercept, we simply plug in 0 into x. So we get h of 0 is equal to, and I can plug it in anywhere, but I'm just going to plug it into the original. So 0 minus 9 over 0 minus 0 minus 3 gives me -9 over -3, which is 3. So I have a y-intercept at 0, 3. Another way you can do that is to take your constant terms in your function and just go ahead and divide them. If the top of the bottom of the rational function are in standard form. Okay. All right. Lastly, our x-intercepts is when we set the numerator equal to 0. So in this case of our simplified equation, so I'm going to take my x plus 3, and that is equal to 0. And so when x is equal to -3, that's when I get a 0 for y. So my x-intercept is at -3, 0. So I got a lot of things going on here. 6 things. That, a whole vertical asymptote, a horizontal asymptote, and then we're going to, if we need to, we'll plug in points to figure out what the rest of our graph looks like. Okay, so we start by graphing all of our details. I'm going to go to 0, 3 to graph my y-intercept. I'm going to go to -3, 0 to graph my x-intercept. My whole is at 3, 1.5, so like right there. And I have a vertical asymptote at -1. So kind of hard to see. And a horizontal asymptote at y is equal to 1. Alrighty, so I know in order to be a function that every input will have an output, a consistent output. And so I know by looking at the way this graph is set up that I'm going to have 2 sections of graph because I have one vertical asymptote. Because I only have one vertical asymptote. Okay. I also know that these sections are either going to be in this section or this section, but they can't be in both. Okay. And then the second part is either going to be in this area or this area. But again, it's not going to be in both. So I'm going to look at my graph. Again, I have points here, I have a hole here, and a point here. So in the orange section, is my graph in this area or the bottom area? And I already have a point in the bottom area, so the graph is going to stay in that bottom area. So what this is going to look like is it's a graph that goes close to the horizontal asymptote but doesn't touch it, goes through the x-intercept, and then also gets close to the vertical asymptote. Same thing on the other side. As you can see, we have points in the top section, so it's going to go, it likes to get really close to the asymptotes. They're like magnets. Okay, so it's going to look like that. And that's that. We didn't have to do any extra points because we could predict where the graph was going to be in each one of those sections. All right, so we're moving on to the next one. Go ahead and graph this one by hand. This one is a little funky. So we're already factored, and I can see with 3 over x, let's go ahead and start with our y-intercept. We're going to have a y-intercept is 0 for x, so 0 comma something. So I'm going to plug it in. 3 over 0. That's undefined, so we have none. Okay, no y-intercept. All right, next, x-intercept is when the top is equal to 0. Solve for x. I don't have one. So again, this is none. A hole. Do we have any factors that cancel? No, we have none. Okay, vertical asymptote. Okay, now we get something. So the factor from the bottom equal to 0. So when x is equal to 0, we're going to have a vertical asymptote. All right, well, now is the slant asymptote. So our function is 3 over x. So the degree on the top is 0, and the degree on the bottom is 1. So who wins, the top or the bottom? And that's the bottom. So this is a Bobo situation. We're bigger on the top, so 0. So my horizontal asymptote is going to be, I have a horizontal asymptote, at x is equal to, y is equal to 0. And then we'll figure out our number line in a minute. Okay. All right, I don't have very much to graph this time. So I'm going to start by just graphing in my horizontal and my vertical asymptotes. So my vertical asymptote is at x equals 0. And then my horizontal asymptote is at y is equal to 0. And then I go back, I look to see, can I plug in any points? Let's see, no hole, no intercepts. So that's it. We need a number line here. We need to know where this graph is going to be. Is it going to be, so left of the asymptote, is it going to be in the top or the bottom section? And right of the asymptote, is it going to be in the top or the bottom section? So for the number line, what we use is, we use any, so we're going to plot any x-intercepts or vertical asymptote values. And I see I have a vertical asymptote at y is equal to 0, and that's it. So that's all we're going to test. So what we do is we test a number to the right, so a right of the vertical asymptote, and to the left of the vertical asymptote. So to the right, let's plug in something like 1, and on the left, let's plug in something like -2. So I'm going to be like 3 over, so into the original equation, 3 over x. So my x is going to be 1. Is that value a positive or a negative value? That's a positive value. And so I can see that in my graph, I want a graph where the values are going to be positive, so up here. So we look like this. We get close to the vertical asymptote and close to the horizontal asymptote. Okay. In the section that is to the left of our graph, of our vertical asymptote, so I'm just going to plug in -2. So I have 3 over -2. Does that give you a positive or a negative value? It gives me a negative value. So is the graph going to be up here or down here? Where are the values negative? The values are negative below the horizontal asymptote. So we're going to get close to the horizontal asymptote. I'm going to sketch it in and get close to the vertical asymptote. And that's our graph. All right, one more. We have, let's factor the top and factor the bottom. So I get h of x is equal to x plus 1 times x minus 2 over x minus 1. All right, nothing cancels, so I have no holes. My vertical asymptote, I check out from the bottom here. So we get x minus 1 is equal to 0. So when x is equal to 1. All right, next are x-intercepts. Those are the factors. We take the factors of the top and set them equal to 0. So we get x plus 1 is equal to 0, and x is equal x minus 2. Sorry. Okay. X minus 2 is equal to 0. So this is when x is equal to -1 and when x is equal to 2. So I have two x-intercepts at -1, 0 and at 2, 0. And then I have a y-intercept when I can just take the constants of the original and divide them. So I have a y-intercept at 0, -2 over -1, which is 0, 2. This time, the degree of the top is bigger than the degree of the bottom. So this is bottom. It doesn't give us a horizontal asymptote. It gives us a slant asymptote. Remember, bigger on top, none. But that doesn't mean no asymptote. It just means no horizontal asymptote. So what we're going to do is we're going to divide. And we're lucky this has a linear factor on the bottom. So I'm going to set up using synthetic division. What is the 0 of the bottom? It's 1. And then I put in my coefficients. 1, -1, -2. I get 1. 1 times 1 is 1. That gives me 0. 1 times 0 is 0. So a -2. So remember, this equals, so x squared minus x minus 2 over x minus 1 would equal x minus a remainder, 2 over x minus 1. When the x's get really big, the remainder goes to 0, so it doesn't matter. So our horizontal asymptote is going to be, or our slant asymptote is going to be y is equal to x. All right, we're going to start graphing these things in, because this is a lot. Okay, here we go. We're going to start with our vertical asymptote at x equals 1. Okay, got you. No holes. Okay, I have two x-intercepts and a y-intercept. So x-intercepts -1, 0 and 2, 0. A y-intercept of 0, 2. Everything is coming together. And a slant asymptote at y is equal to x. So, like, you're just going to graph in the line y is equal to x. These little diagonal boxes play tricks on my mind sometimes. So, same idea. We're going to be looking to the right and to the left of the vertical asymptote. So to the right of the vertical asymptote, does the graph exist in the top above the slant asymptote or below the slant asymptote? You can see it's below, so it does the same thing as a horizontal asymptote. The graph gets really close to this slant and then really close to the vertical asymptote. In the part that is to the left of the vertical asymptote, is the graph above or below the asymptote? Well, it is above. So we're going to go up like so. And that is that.